This is for ISOL 631 at the University of the Cumberlands. This is for textbook security policies and implementation issues. This lecture is on Chapter 10, IT Infrastructure Security Policies. So information technology infrastructure security policies are represented in many types of policy documents depending on an organization's network and infrastructure needs. For example, a national telecommunications company network policies will look very different from those of a regional retailer. These differences stem from different cybersecurity risks. They also present organizations with different choices to define and make security policies. However, as much as organizations differ in size and mission, all networks must provide layers of security, from the perimeter through the network layers to ultimately the data being accessed. Information security professionals must understand well these common IT infrastructure needs and policies. If you do understand these fundamental policy concepts and focus area, you'll be able to navigate infrastructure policy documents regardless of how they are organized. The key purpose of infrastructure security policies is to provide technical knowledge of interaction, various levels of the network, placement of key controls, and the types of risks that will be detected and guarded against. This chapter discusses common IT infrastructure policies. It's not possible in one chapter or even one book to cover all possible security policies an organization needs. This chapter illustrates key points by selectively discussing some points in more detail. The intent is to create an understanding of an IT infrastructure policy's basic infrastructure. So the learning objective of this chapter 10 describes the different information security system policies associated with the IT infrastructure. So topics we will cover include what the basic anatomy of an infrastructure policy is, what common workstation domain policies are, what common LAN domain policies are, what common LAN to WAN domain policies are, what common WAN domain policies are, what common remote access domain policies are, what common system and application domain policies are, what common telecommunications policies are related to the IT infrastructure, and some IT infrastructure security policy best practices. So the key concepts from this chapter will be elements of an infrastructure security policy, policies associated with various domains of a typical IT infrastructure, and best practices in creating and maintaining IT policies. So the goals of the chapter are to explain the basic anatomy of a policy, explain layered security, why it is important, understand types of security control requirements for IT infrastructure domains, identify the differences between core domain policy requirements, describe the common policies by domain, and describe best practices in creating and maintaining domain policies. So the key purposes of an IT infrastructure policy are to provide technical knowledge of the interaction of various layers of the network, the placement of key controls, and the types of risks to be detected and guarded against. So 3 ways to organize policies. Many individual security policies look alike. They often follow the same look and feel. This makes them easy to read and understand. Challenge is how to organize policies as a collection. Policies need to be easily accessible aligned to how an organization manages its IT environment. There's no limit to the number of ways to organize a collection of policies. Three common ways, though, are to organize by domain, by functional area, or by layers of security. Creating policies by functional area of responsibility is a challenge. The advantage of this way is that the policies can be tailored for a specific audience. Disadvantage is that the functional areas may change due to organizational alignment. This means policies may have to change too. Typically, organizing policies by functional area is the approach used in mature companies whose processes rarely change. Creating policies by layers of security is also a challenge. Core principle in the information security is the concept often referred to as layers of security, layered security, or defense in depth. Example of layers would be a simple security controls placed within the network parameter, like a firewall, in an operating system, like a server, in code, such as an application, and in storage, secure storage of a database. Ideally, these controls collectively provide layered security. The challenge is that technology is constantly changing and evolving. Eventually, the number of layers depend on the company. For example, should telecommunications be considered a perimeter layer or its own layer? There's no right answer or industry norm. So the 7 domains of the typical IT infrastructure, like the image shown on the screen. This is one logical way to view requirements and policies. 7 domains are common taxonomy or classification system used across the industry. This taxonomy clearly illustrates how each domain can be used to create a layered security approach. For example, the workstation domain may involve pirated software. The LAN domain can scan emails for viruses, while the remote access domain deals with the virtual private network tunnels. Different domains can have different security requirements. The problem with organizing policies by domain is that many issues pertain to multiple domains. For example, virus control is concerned for workstations and servers. Requirements may vary a bit. However, the core need and control solutions would be the same. There are few crisp bright lines between these domain areas. You need to ensure the requirements between the domains do not conflict. To give it a simple example, a conflict could arise from requiring passwords of 6 characters on the workstation, but 8 characters on a server. This minor difference could make it difficult or impossible to implement a single sign-on solution. The number of documents can vary greatly between organizations. Some organizations combine related issues into a single policy document. For example, a workstation policy may combine preventing pirated software with virus protection requirements, or other organizations may treat this as 2 separate policy standards. The number of documents an organization uses depends on its need and capacity to deploy. The goal is to develop a coherent set of documents that do not require constant revisions to stay current and relevant. When there is overlap, reference the corresponding document rather than duplicating content. Here are a few common reasons why policy documents vary from one organization to another. Organizations use unique sets of technical tools and hardware. Risk management practices are often customized to an organization, and the size of IT departments varies according to business needs. So creating a policy documents should differentiate between core requirements and technological requirements. It should follow a standard format, should remain relevant without constant modification, and not contain duplicate content. So the basic anatomy of policy starts with understanding the different types of documents that capture the domain security control requirements. 4 common documents are the control standards. These are policy documents describing core security control requirements. Baseline standards are technical documents describing security controls for a specific technology. Procedure documents, those are processes to implement control and baseline standards. Guidelines, these are optional documents that include parameters and recommend policies, standards, or procedures. And a dictionary. It's a common taxonomy to be used in the policies that defines the scope and meaning of terms used. Different organizations use different terms. Some people refer to control standards as core policy statements. Baseline standard is also called a technology minimum security baseline, or MSB. The key point is that policy documents make a distinction between core policy requirements and requirements unique to technology. For example, a core requirement may be change passwords every 30 days. You may have 2 different baseline documents describing how to configure Microsoft and Unix servers to achieve the core requirement. So the workstation domain. Workstation domain policies relate to any computer device used by an end user. Often refers to the user's desktop or laptop computer. Workstation can be any user device that accesses data, such as a smartphone. These devices may not be operating within a protected office or data center. Encryption is a common method used to protect mobile devices. By encrypting a device's hard drive, you protect the data even if the device is lost or stolen. The encryption approach encrypts the data when the device validates the user's credentials, such as, or unencrypts the data when the device validates the user's credentials, such as an ID and password. If the device is lost or stolen, the wrong credentials are entered, the device can be wiped out its data. If someone scans the hard drive without logging into the device, the data remains encrypted and protected. Some devices can send a signal to the device to wipe its data in the event the device is lost or stolen. Mobile devices, by their nature, are distributed. This means policies used to address unique monitoring and patching challenges in a distributed environment. How you connect, monitor, and patch a mobile device is a different challenge than doing the same from a desktop in an office or a server in a data center. So you have the control standards for the workstation domain. You have the device management, user permissions, and align with the functional responsibilities. Baseline standards, specific technology requirements for each device, and review standards from vendors or organizations. And for procedures, you have step-by-step configuration instructions. And for guidelines, you have acquisition, which preferred vendors you would purchase from, and description of threats and the countermeasures that you would use. The LAN domain, or a local area network. LAN domain refers to an organization's local area network infrastructure. A LAN allows 2 or more computers to connect within a small physical area. The small area could be a home, office, or a group of buildings. LAN security policies focus on connectivity, such as defining how devices attach to the network. Policies also define how to control traffic such as true segmentation and router filtering. LAN configuration issues are similar to those for workstations. However, the primary difference is administration. The LAN domain is often centralized to a small group of network administrators. This means devices are less distributed and are under tighter control. So the control standards will be the firewalls, the denial of service, and align with the functional responsibilities. Baseline standards, specific technology requirements for each device, and we review those standards from vendors or organizations. The procedures will be step-by-step configuration, and guidelines will be acquisitions and description of threats and countermeasures. The LAN to WAN domain. So the LAN to WAN domain refers to the technical infrastructure that connects an organization's LAN to a wide area network, or WAN. The main concern is controlling network traffic between the outside network, or the WAN, to the private network, or LAN. The LAN to WAN domain denotes, for many organizations, its connection to the Internet. This connection represents significant risk. LAN to WAN security standards often focus on how to configure devices to maintain message and transaction integrity. Establishing secure point-to-point communications is an important part of the connectivity through the Internet. The Internet should never have a direct connection to the organization's private network without the traffic being heavily filtered and inspected. An important policy concern is how to filter traffic between the Internet and the internal network. Additionally, many organizations have an Internet presence. This has the additional challenge of serving contents to the Internet to customers and businesses. These public-facing websites often provide access to internal resources such as databases for product information. As a result, they are a prime target for hackers. The LAN to WAN key standards define the security requirements to harden Internet-facing servers, filter traffic between these networks, and monitor for breaches in security. Although there are other policy requirements such as defining what data the public can access, these standards generally represent the core requirements. So the control standards are access control to the Internet and the traffic filtering. Baseline standards should be specific technology requirements for parameter devices. Procedures would be step-by-step configuration. And the guidelines would be for the DMZ, or the demilitarized zone, and the content filtering. The WAN domain. The WAN is a network that covers a large geographic area. The Internet is an example of a WAN. A private WAN can be built for a specific organization to link offices across the country or globally. These types of WANs are constructed using dedicated leased lines, satellites, and/or microwave communications. Typically, the LAN to WAN domain addresses many of the WAN connectivity standards. As a result, this domain standards tend to focus primarily on the WAN build-out and supporting components. Some organizations may not have any WAN-specific standards or policies. This is because many of the topics are often included in other domains. So the standards control the WAN management, domain name services, router security, protocols, and web services. Baseline standards will be review standards from the vendors or other organizations. Procedures will be step-by-step configuration of routers and firewalls, and also change management. And the guidelines when and how web services can be used, and also the domain name service management within the LAN and WAN environments. The remote access domain. The remote access domain refers to the technology that controls how end users connect to an organization's LAN remotely. Example is someone needing to connect to the office network from his or her home or on the road. The focus of security standards in this domain is on remote user authentication and secure connections. Creating a remote computer environment that is secure is a challenge. Beyond authentication and connectivity, need a secure remote device. Some standards require all remote users to use employee-owned laptops. This allows the organization to control the remote device itself. These types of business choices drive what standards you see in this domain. So the control standards would be the VPN connectivity and also the multi-factor authentication, like user ID and password. Baseline standards would be the VPN gateway options and client options. Procedures would be the step-by-step VPN configuration and debugging. And guidelines would be description of threats and security of remote computing environments such as working from home. The system application domain. So the system application domain refers to the technology, application software used to collect, process, and store company data. This domain covers a broad range of topics from the system that process information to data handling. This domain covers all security issues associated with applications. Consequently, the types of standards in this domain are diverse. Documentation collection in this domain can be quite large. It's important that the collection be well organized. Here are a few examples of what should be considered in organizing the collection of system application domain policies. Types of technologies deployed, use of technologies such as application servers versus database servers, authentication methods, authorization methods, testing requirements, transition applications from test to production, and secure coding requirements. So the control standards for this domain would be the firewalls, denial of service protection, and align with functional responsibilities. Baseline standards would be specific technology requirements for each device, and review standards from vendors or organizations. Procedures will be step-by-step configuration, and guidelines will be acquisitions from vendors and description of threats and countermeasures. The telecommunications policies. So telecommunications generally refers to any technology, service, or system that provides transmission of electronic data and information. Telecommunications may be wired or wireless. This includes voice and data networks, telephones and other wireless services, messaging, and direction services. High-speed data communications, facsimile devices, personal digital assistants, tablets, network service switches, or any other device, service, or system used in the transmission of electronic communication. It's not surprising that such a broad topic crosses over into other domains that deal more with data connectivity. For purposes of this chapter, the telecommunications discussion focuses on devices such as the telephones, fax machines, modems, and smartphones. So the control standards would be protect with a FIPS encryption, segregation of data and voice networks. The baseline standards would be specific technology requirements for each device, review standards from vendors or organizations. Procedures will be the step-by-step configuration, and guidelines may include voice over IP system architecture and security guidelines. So best practices for IT infrastructure security policies. The volume of infrastructure policies can be quite large depending on your organization's need. For example, the more diverse technologies deployed, the greater the number of baseline standards required. It's important to define requirements for standards in a methodical way. This chapter has discussed the requirements based on domains. More than one approach works. Many organizations first select a framework, such as the ISOL or COBIT. Then they develop requirements and standards based on the framework. But you should not reinvent the wheel. There are rare instances where you need to develop original content to create a new policy. More often, you modify an existing sample obtained from a reliable source. Before you create content for a specific topic, see what others have already done and adopt that work to your specific needs. Some sources for security policies and standards include the following. U.S. government offers hundreds of standards through NIST. Private organizations such as SANS sell pre-written security policies. Professional associations offer security policy examples to their membership. Those include the IIA, or Institute of Internal Auditors, and the ISACA, that's the Information Security and Control Association. And you can contact vendors of your IT products to find out if they offer sample security policies. You should not impose strict access controls on your policies and standards. You should make them freely available to everyone expected to follow them. These documents reinforce security awareness messages. You should keep content cohesive. While standard boilerplate security policies are easily acceptable, they can conflict with one another. The conflicts can be in many levels, from approach to specific requirements. When developing a document, focus only on the subject it covers. Compare the content with related topics. If you need to refer to other topics contained in other documents, do not repeat the content. Simply reference the other related document and the one you have developed. When it's finished, look at it as a complete end-to-end story of how to control risks. This end-to-end view allows you to adjust for inconsistencies and close gaps. Keep content coherent. Maintain the same voice throughout the single document. Do not add more information when it is necessary than to convey the information. Do not stray from the message. You should make your library as searchable as possible. When implementing your policies, make it easy to locate relevant documents by indexing them with keywords and phrases. Federate ownership to where it best belongs. Over time, you will find that non-security personnel are adept at producing policy documents. This is especially true for creating procedures that use every day. If you work on building maintenance with data center operators and administrators, you can often obtain their help in preparing policy documentation. So the roles and responsibilities include Information Security Manager. They do policy creation, application, and alignment with organization goals. And the IT Auditor, who ensures that controls are in place per policy. And the System and Application Administrator. They apply controls to the workstation, the LAN, and LAN to WAN domains. With a lack of controls, all the following and more are possible. Workstations would have different configuration. LANs would allow unauthorized traffic. WANs would have vulnerabilities. Network devices would not be configured the same. And users would have access to data they are not directly working with. So in summary, this chapter discussed security documents that relate to each other each domain of a typical IT infrastructure. We'll learn there is more than one one approach to creating standards. It's important to separate core policy language from specific technology configuration. One way to approach this is to have two separate documents, such as control standards and baseline standards. Supporting documents include procedures and guidelines. Collectively, these documents represent a comprehensive way of addressing risk. This chapter examined both the form and substance of many standards. In fact, the volume of policy and standard topics is enormous. So no one chapter can cover it in great detail, every aspect of infrastructure policies and related controls. Policies that are well organized are likely to be better understood and more fully adopted. Early adoption of security policies can be a source of pride for both the individual and the team. Organizing this material in searchable and usable manner is important to drive this understanding. This chapter also discusses how to categorize various documents in the library and how to describe their relationships. Finally, the chapter examined the best practices that are included in a number of sources for policy and standard material. Organizations rarely create new policies from scratch. It is far better to leverage best practices, security frameworks, and related policies. Thank you.